So in this part of the lecture, we're going to discuss the use of a measuring tool in our circuits, and such a device that is capable of measuring multiple things, as we've seen in our labs, is called a multimeter. And there is a short section in the chapter discussing how you might use a measuring device in particular to measure current and voltage. And so that will be the focus. But what you've been making use of in lab is called a multimeter because it is capable of measuring multiple things. And so it's packaged multiple tools into one device. And one thing a multimeter is capable of measuring is current. And if you're using it to measure current, then it's called an ammeter, and it's measuring amps. And on the multimeter that's shown on the screen, this is the one that we would typically make use of if we were in person. It's a little more expensive multimeter than the one that you have in your kit, but the one that you have in your kit will have similar functionality. And typically to measure amps, you're looking at one region of the multimeter that is labeled with an A. And if you dial to that region, then you're measuring amps. Also, multimeters are commonly packaged with the ability to measure voltage. And if you're using it for that purpose, then it's being used as a voltmeter. And on the multimeter that's shown in the photo, that would correspond to dialing into the volt range of the multimeter, which is on the upper left. And then you can also use a multimeter to measure resistance, in which case it's called an ohm meter. It's measuring ohms. And on this multimeter, that would correspond to the settings in the lower right. So here it's measuring resistance, current, voltage, depending on where you've set the dial. And then another functionality that this multimeter in the photo has that the one in our lab kits does not have is this one has the ability to measure capacitance, and that corresponds to the region in the upper right. So a little more expensive multimeter would have the capability to measure that as well, and that would be measured in farads. And then they can come with other functionality as well. So depending on what your needs are, you might look for a multimeter of a certain type to measure what needs to be measured. But it's very common to have at least the ability to measure voltage, current, and resistance, and then capacitance is like a next level up to be able to measure that. What we focus on in this chapter is the use of a multimeter as an ammeter and a voltmeter. And an ammeter, again, measures current. And there's a specific way that we set the multimeter into the circuit when we're using it as an ammeter, and that is that we need to break the circuit and insert the ammeter so that the current passes right through the meter. And so an example circuit is shown on the right. We've got a battery with an EMF and an internal resistance. So this is the battery. And then some external resistances, R1 and R2. And so it's a single loop circuit with the current I traveling around it. And if we wanted to measure that current I, we would have to choose to break our circuit at some point and insert our ammeter so that the current passes through it. So for example, we could choose to break the circuit between points A and B. And if we did that, then we would break the circuit between those 2 points, disconnect the wiring, and then insert the multimeter so that the current that it needs to measure passes right through it. And in this way, the ammeter is going to receive the full current passing through it. So the full current I that it's attempting to measure is going to pass through it. And so to minimize introducing a disruption to your circuit, a good ammeter should have very little internal resistance. effectively, an ammeter will always have some small amount of internal resistance, and we might put that in as a small lowercase r as to represent its internal resistance. For a good ammeter, we want to make sure that internal resistance is very small to avoid disrupting and changing the amount of current that flows in the circuit. And sometimes you'll be asked to consider that internal resistance of the ammeter in your calculations, but most usually not. If it's an ideal ammeter, then we can ignore that internal resistance. This idea of breaking the circuit to insert the ammeter is something that takes practice, and you had a chance in last week's lab to practice this, and you'll have a chance again in this week's lab to practice this some more. The other way of using a measuring device that's discussed in this chapter is the use of a voltmeter. So now we're turning the dial on our multimeter to measure volts. And a voltmeter is used to measure potential differences or voltages. And it's measuring that potential difference between 2 points in the circuit. And so a voltmeter does not require breaking the circuit. Instead, a voltmeter is connected across the 2 points that you're trying to measure a potential difference between. And an example on this circuit is if we wish to measure the potential difference across R1. So we're trying to figure out what the potential drop is across the resistor R1. Then the way that we would want to connect our voltmeter is to connect it across R1. And so we might clip our voltmeter to points C and D, perhaps with alligator clips. Those represent the ends of the leads of resistor R1. And by clipping to those 2 points, we'll be measuring the voltage drop across resistor R1. We want to avoid, with the attachment of the voltmeter, drawing off significant current to this new branch of the circuit that we've installed, so as to avoid taking away any of the original current that would have flowed through R1. We've now affected the circuit so that a slightly smaller amount of current is going to travel through R1. And so it's no longer I, as it was originally, because we've drawn off a small amount of current into the multimeter. So a good voltmeter should have a very large internal resistance to avoid affecting the operation of the circuit that we're trying to study. So always when you are using measurements in a circuit, if the internal resistances of the measuring devices are comparable to the resistances in the circuit, then you have to recognize that you might be disrupting the circuit itself just by attaching the measuring device. And that's all I really want to say about these two topics. I'm not going to work an example problem, but rather I'll give you a lecture quiz question to think about where you might insert an ammeter to take a measurement of what's described here. And then when we come back, we'll talk about an RC circuit.